Okay, so the other night in the car driving back from karate, you began to think that pi might be
Yes.
repetitive.
Pi.
Okay.
Even.
So let's see if you can sketch out an argument why pi might be repetitive, and maybe even convince us that it is.
So what you do is you pick your number. You pick how long the sequence wants to be.
All right. Well, let's just pick this sequence here: 1, 2, 3, 4, 5, 6. So 6. Let's see if pi has a sequence of 6 digits that repeats, and we can just go with 1, 4,
Well,
1, 5, 9, 2.
since we can't find this sequence exactly, we don't know if this sequence is the one that repeats, but we can tell that there is a sequence that repeats, even if the digits of pi are unknown or maybe random.
Okay.
So for every sequence of 6, there's 10 choices for that number.
Okay.
So that makes there be 1 million possible sequences of 6. And to now be guaranteed that there's a repeat, we need to go 1,000,001 digits in pi, or 1,000,001 sequences of 6, which would be 6,000,006
Okay.
digits.
And then why does that guarantee we've gotten a repeat?
So even if for the first 1,000,000 sequences you list out all of the possible sequences, that's the maximum length you can go without a repeat. But then the next one guarantees that you'll see one that you've seen before.
Okay. Can you sketch out this argument? I just want to make sure you understand. So we'll do it again. Let's just keep it with 6 digits.
Yeah, so I think what you do is you basically look at pi as an infinite decimal of randomly selected integers in each spot. So basically, if you go for long enough, you will see this sequence again, and I guess in this case, since you have 6, if you go 6,000,006, you will see all possible sequences, and then plus at least one repeat. It might not be this one.
Okay, yeah, that's close. That's not exactly right. We're not guaranteed to see this one.
No, we're not.
It's not necessarily the case that this sequence repeats.
Yeah, but if you go 6,000,006 decimal places, even if you make the number, I'm going away from pi here, but if you make the number so that it has all possible 6-digit sequences in it, if you go 6,000,006, you will have one more sequence, and it has to repeat one of those sequences. It doesn't have to be this one.
Okay, great. So for pi, if we're looking for a 6-digit sequence that repeats, we look at the first 6 million digits after the decimal point first. And what's the question we're asking there?
So do we have any repeats in there?
And if we do,
we're fine.
then we got to repeat.
Well, we might not.
If we don't,
then we just go 6 more.
And then what happens?
Then we have to have a repeat.
Then we're guaranteed to have a repeat. And do you remember what that mathematical principle is called?
Is that the pigeonhole principle?
That's right. This is the pigeonhole principle. Okay, so we've checked it for 6 digits. So why then do we think now that pi is going to be a repetitive number? Why is there going to be an arbitrarily long sequence? Like if I ask for 1,000 digits or 1,000,000,000 digits.
This works with any number. It doesn't have to be 6. For any sequence of digits, you can go far enough into pi that you're guaranteed to either see a repeat of this number or see a repeat of some sequence you saw along the way of the length that you want.
Okay, great.
And this makes me think that the proof might be easy because I can't immediately think of a number that isn't repetitive.
All right, let's go to the next video.